Hello and welcome to Math 251, Calculus 1 here at Cañada College. My name is Lapuz and I'm the instructor for the course. In this video, we're going to take an overview of section 4.7. The general objective for this section is to set up and solve optimization problems. Optimization problems can come in many flavors. They're basically something that you want to optimize. You want to find the maximum or minimum values of something. You'll get problems like this one where you have to find the dimensions of X and Y for a fence that you're going to create, and you want to maximize the area given some fixed perimeter. Another common problem is cardboard, where you cut out the corners of the cardboard and make a three-dimensional box out of it. And the question here is, what should X be? What should the dimensions of those squares be that you would cut out so that you're going to maximize the volume of the box? Another common problem is the problem where you have a certain speed that you can run along a beach, and you have a certain speed that you can swim in the water. And so in a scenario like this, what we would do is you would try to find a point on the beach where you would stop running and start swimming towards a particular island or something. So you're going to try to maximize or minimize the time that it takes for you to get from the house running along the beach and then swimming into the water to get to your point. This is actually an interesting problem because this is a problem where a corgi, you would say that this particular mathematician here, Tim Pennings, was walking along the beach and would throw a ball out into the water and have his dog try to fetch that. Now the dog would run along the beach and at some point would start swimming towards the ball in the water. And so he tried to figure out the times or the places where he would throw the ball and where the dog would run up on the beach and then swim in the water to try to minimize the time it would take for that dog to fetch the ball that's in the water. So there's an interesting article, again by a mathematician named Pennings, about his corgis running into the water to fetch the ball. So you should look that up. Another common problem is try to inscribe a rectangle within another shape, like an ellipse or a circle or maybe even a parabola, to have some corners of those rectangles, and what should the dimensions be to try to maximize this. So all these things have a common theme. Of course, you're trying to maximize it. But as you're trying to maximize it, there should be some sort of algorithm to follow so that you can do these problems. And that particular algorithm goes like something like this, where you have to find the variables that you're interested in using. And if you need to draw something, that would be appropriate. And then you have to find an equation that you're trying to maximize, a quantity that you're trying to maximize or minimize. And it'd also be good to find the range of values that would make sense, so that you can know when your answer would make sense or not make sense. And then once you have this formula that you're going to try to maximize, you would find all other equations that would relate all the different variables so that you have a function of only one variable. And so those are sometimes called constraints. A constraint on a couple of variables so that you can use that equation to write your quantity that you're trying to optimize into a function of just one variable. Once you have that, everything else comes as follows. You find critical points. If you have endpoints, you can use the extreme value theorem, or you can just show that what you found is a local maximum or minimum. And so by that time, it's just the regular calculus mathematics that you're going to be doing. So the tricky part is setting things up, finding the equations, finding the constraints. And once you have that, it's back to calculus. So that's a general idea, just a bunch of word problems. But if you follow through our step-by-step process, then I think you'd be okay. All right, good luck.